Problem 35, we're supposed to write the following polynomial in vertex form. We want to do that by making it so that part of the polynomial factors to a perfect square trinomial. And we can figure out how to do that by taking half the b value and then squaring it. So our goal is to use that little formula to figure out what number we should add and subtract so that part of it becomes our perfect square trinomial. In this case, the b value is 8, and so half the b value squared would give us 16. That's what we'll add and subtract to our rule in the spot shown. Adding and subtracting 16 at the same time makes it so that overall we're just adding 0 to the equation, and so that doesn't change the value of anything, but we're going to use the positive 16 and the negative 16 separately. The positive 16 is going to become part of a polynomial x squared plus 8x plus 16, which would factor to x plus 4, or we can just write that as x plus 4 squared. Then the negative 16 will combine with the negative 5 to make the extra number that's on the outside. And so now we have a perfect square trinomial, which is this part here, and then the extra number on the outside. And so together, those two things make vertex form. And that's our final answer. Problem 36 is the same as problem 35 with just a different equation. We want to rewrite this in vertex form. And so we're going to take half the b value and square it. The b value in this case is negative 10. And so half of that squared is 25. That's what we'll add and subtract to our rule. So now we're going to look at just the first three terms, x squared minus 10x plus 25. And again, that would factor to x minus 5 and x minus 5. Or in other words, we can just write that as x minus 5 squared. And then the negative 25 and the 2 become the extra number on the outside of the parentheses, negative 23. Problem 37, we're supposed to solve the quadratic equation. We've talked about 3 different ways of solving quadratic equations. That's using quadratic formula, factoring, or by completing the square and then solving from vertex form. At the moment, this equation is written in standard form, so the first thing I'm going to do is identify the discriminant so that I can tell how many and what type of solutions I'm going to have. That's also going to help give me some guidance as to which method I should use to solve the equation. So the equation's already equal to 0, so I can identify my a, b, and c values as 2, negative 5, and 7. The discriminant is b squared minus 4ac. And that gives us a result of negative 31. Because of the fact that the discriminant is negative, we're going to end up with 2 imaginary solutions. That means this is not factorable. So we either have to complete the square and use vertex form or use quadratic formula. I wouldn't complete the square with this one just because the b value is an odd number rather than an even number, and also because the a value is not 1. So I'm going to go ahead and use the quadratic formula to solve this one. So we'll put all of our numbers in the appropriate places. In this case, I don't have to recalculate the part under the square root because that's the discriminant and I've already done that calculation. Now I just need to simplify my fractions, and that's as far as we can take it. We end up with 5 over 4 plus or minus I root 31 over 4. The I is necessary because we ended up with a negative under the square root, and 31 is prime, so that square root will not simplify any further. Problem 38, again, we're supposed to solve a given quadratic equation. It's already equal to 0, so I'm going to go straight to identifying a, b, and c so that I can calculate the discriminant. I end up with positive 28 as my discriminant, which means I'm going to have 2 irrational solutions. Again, I'm going to go ahead and use quadratic formula to solve this one. Then when I simplify those fractions, this time 28 is an even number. It's not prime. It is possible to break that number down further and possibly simplify the square root. So the square root of 28 simplifies to 2 root 7. And then I can go one step further to simplify those fractions. Negative 2 over negative 6 simplifies to 1/3. And we can do the same type of simplification in the second fraction as well. So 1/3 plus root 7 over 3 is our final answer. 39, we're supposed to solve by factoring. You always want to look for a greatest common factor when you're factoring, but in this case, the terms in this polynomial don't have a greatest common factor. So the best method to use for this one, because it's a quadratic trinomial where the a value is not equal to 1, is the AC method. First step in the AC method is to multiply the a and c values together. Then we want to figure out the two numbers that multiply to negative 40 and add to 3. So after listing a couple possibilities for multiplying to negative 40, we discover that negative 5 and positive 8 would be the combination of numbers that would multiply to negative 40 and add to 3. So we'll rewrite the original equation, but instead of writing 3x, we'll split it apart into the two numbers that we chose, negative 5x and positive 8x. Now we have a polynomial that has 4 terms, so we can split it into 2 groups and factor by grouping. And so our result in the parentheses is 2x minus 5, and then outside the parentheses we have x plus 4. Those become our 2 factors. Now that we have it in factored form, in order to solve this equation, we just need to set each factor equal to 0 and solve those equations individually. So we'll have x plus 4 equals 0 and 2x minus 5 equals 0. Solving for x within each one of those gives us negative 4 as one solution and 5/2 as our other solution. Problem 40, we're supposed to solve by factoring. Some of you may have a typo on your sheet. It was supposed to be negative 20x on the right-hand side instead of negative 10x. Leaving it as negative 10x gives you a polynomial that can't be factored. So once you fix that typo, you want to get the equation equal to 0. And so we'll add 20x to both sides and then add 65 to both sides. Now that the equation is equal to 0, we can solve by factoring. This is a quadratic trinomial where the a value is 1, and so we don't need to use the AC method. We can just go straight to setting up our 2 sets of parentheses and figuring out what 2 numbers multiply to 45 and add to 14. Both numbers are going to be positive because we're multiplying to a positive number and adding to a positive number. And so the 2 numbers that would fit that pattern would be 5 and 9. Those 2 numbers multiply to 45 and add to 14. And our last step is to set each factor equal to 0 and solve for x. And so we end up with x is equal to negative 9 and x is equal to negative 5.